Ladies and gentlemen, hello and welcome back once again to the only coast to coast radio show in the US of A that's all about the information economy. It's called Inside Analysis. Yours truly, Eric Kavanaugh, here with our good buddy Yves Mulkers, dialing in from 7W Data, my European doppelganger, as we call him. And we have a great guest today for you, Jay Gopalakrishnan. He is the founder of a company called Knowi. That's Knowi. When you know better, you do better. That's what we're going to talk about. A new way of doing business intelligence, decision support, analytics, whatever you want to call it, getting value from your data, being able to analyze and understand your data and then do something with it. And I've got a few thoughts about that, having been in this industry for almost a quarter of a century now. Time flies when you're having fun. And what I want to mention to Eve to start us off here is that, when I think about how we got here, the old engines, many of which were designed 3 decades ago, 2 decades ago, they were designed with certain constraints in mind, the hardware realities, the realities of business, the amount of data that was available, the kind of data that was readily available. And so all these tools and technologies were built up over time into an ecosystem around data warehousing. We took a couple left turns here and there. One with the whole Hadoop movement was an interesting experiment in how to work with data. And I think we learned a lot of lessons in those days about distributed computing, federated computing, you might want to call it. Very interesting challenges you face in that world and the scale, of course. And then you look at the data, the whole big data era, how that changed things, how that changed mindsets, how that opened doors, how that changed the way people think about data and how to put together a picture of your business to understand what to do. And of course, the timeliness. How quickly can you do these things? Can you pull the data in and analyze it that day? Do you have to wait till the next day? Is it a batch orientation? Streaming? We got Kafka, Pulsar, Flink, all these new engines or relatively new engines coming out, really changing how you can access your data. So my question to you, Eve, is where do you think we are now on that spectrum? Because it seems to me we are at a very significant inflection point, and there are new ways of doing this that do not require all the heavy lifting we've done in the past. But what are your thoughts, Eve?
Well, I would quote on the heavy lifting. I think we still do that. If you see how it's going with semantics and the large language models that are now supporting generative AI and the decision based upon your data, it's the heavy crunching that happens before, and then you can get the insights afterwards.
Hmm.
Before, every time that you were building a data warehouse, we were doing the modeling, doing the pipelines and everything like that. And now it feels like you're taking this part a bit further, a bit earlier in the pipeline and preparing on that. So the semantics are helping more and more, whereas before you had to do the analysis, understand the business, and this prepackaged type of knowledge didn't exist at that time. So that's where I see that generative AI really is augmenting the way that we build these information systems, as we've been discussing as well before, Eric. Call it data warehouses, which is just the storage of your data. But like you said, with the coming of the clouds, we can easily scale our infrastructure and compute and storage, and that's a big advantage as well, to go much faster on doing that data crunching and preparing everything like that. If I look at the large language models, before it took a whole lot of compute, but the models are becoming smaller. They are becoming just the crunching of the data becomes much smarter. So therefore, I see this the direction where we are going instead of really doing the data modeling. You still need to understand the business, but this has been done, been put into the models for generative AI. So I'm looking forward on where this is going on building data-driven insights and understanding any kind of topic or business which you didn't know before.
Yeah, and that's a really good way to put it, Eve. And maybe I'll bring Jay in from Noe to kind of comment on that. I think that a lot of these innovations come just in time, Jay, because the data changes, the landscape changes, the pace of competition changes, and so the market is always changing around us, and the world is always changing around us. So how do we stay on top of these things? We have to make some kind of change. And you folks at Noe, from what you were telling me, you saw the change happening, and you wanted to make a play to get an end-to-end analytics solution, and you didn't want to go the traditional route, the VC route, for various reasons. So you just did the bootstrap thing and you rolled up your sleeves and you created this new engine called Noe, and now you've got an end-to-end solution, right? Tell us about it and how you built it and what it does.
Thanks, Eric. So I think first of all, for us, it always starts with the customer and the customer experience, right? So
Mm,
when you look at a long time horizon, there's going to be trends and things that come into play. But ultimately, if you're a customer, what are you looking for from data? And data could be spread out all across your enterprise. It could be in different data centers. How do you get a unified view into the data? How do you access the data securely? How do you ask questions against the data and get reliable information from it? How do you build your dashboards, reports, things that get sent to your normal workflow? So those are some of the baseline components, right? And then the technology piece comes into play where how can you make this happen, and how can you make this happen without cobbling together multiple different products that weren't designed to work together in the first place?
right.
You know, so
It's funny.
and then what is it that the industry tells you to do? The industry tells you to do, lift and shift the raw data into a data warehouse, do transformations on top of that data, put BI tools on top of it, data catalogs, governance solutions, and all of those things. And these are all point solutions that were designed to solve one thing that you end up cobbling together, right?
Yep.
And if you go back to the design of the system, is like, how can you do this holistically across from end to end? And that can just drive exponential value for the customer, because you can just get the right information and act on it right off the bat from whatever channel that you work on, Slack, within the BI platform itself, uh,
Yep.
embedded analytics, and so on. So that was a thought process.
Yeah, tell us how are you actually grabbing the data, and at what point do you start doing the analysis? Because I believe you have an agent-based approach, right, where you will deploy agents as many as necessary in some environment. So in a customer's environment, you deploy n number of agents depending upon the workload, and those agents are the ones that actually go and get the data. Is that right?
Close. So we at a broad level, we have a managed service that runs in our cloud that about 70% of our customers use, and then there's a 30% use case where we call it on premise, but it's basically taking the platform and putting it inside your own private cloud or your own data center. The where the agents come into play is like from where Knowi sits, being able to connect into the data, because your data might be in data center A if you're a large customer, and data center B for some other stuff. How do you connect into both of those where there's no access, right? So these agents can run on those within those data centers, execute these queries and multi-source joins and things like that, and then basically communicate back to that core platform to give you the results that you're looking for. So the way it's differentiated from in the modern data stack, so to speak, is without having to lift and shift the raw data where most of that data might be useless, and
Hmm.
putting it into a centralized repository where you still have to do that transformation and putting the stuff back in. You're grabbing what you need. You're grabbing what you need on the fly, and then we give you the options to say, what do you want to do with this data? Do you want to write it to your data warehouse? Do you want to keep it within Knowi? Do you want to have it real-time access? And then that solves that, the for everything under that data modeling part, right? So
Yeah, you know what's
and
interesting is you're giving a great storyline for what folks do in the IoT world,
yeah,
right? Because in IoT, you got all these widgets everywhere. You don't want to have to send every piece of data back over the transom or through the network or whatever, because some of that stuff can be far flung. So what you want to do is identify the signal from the little packets of data and just send the signal, and that's exactly what you're doing, right?
yeah, yeah. Yeah, and the IoT is, it's a great use case for us and our customers in that space, including large ones. But yeah.
Eve, I'll bring you back in to comment on something that I find somewhat amusing. Having, as I told Jay before the show, I've been in this business for 24 years now, going on 25. And so I watched as the data warehousing world evolved, and the whole idea was centralized. You got to pull all your data into one central place and model it accordingly, and then build OLAP cubes on top of it, et cetera. Then what happens? The data lake comes around, big data. Okay, what do they try to do? Put all your data in one place. Right? Again, like, oh, let's get all the data in one place. It's a lot of data, especially if it's big data. And that's why you wind up with a data swamp and all these other strange metaphors spinning out. But to instead be more strategic about what you're doing, to only bring in the data you need for analysis and then make that your approach, That's pretty clever stuff, and you're seeing that now. Even some of the data lake vendors, they used to talk about federated queries. Now they talk about queries on the data lake, for example, which is federated query, basically. But what do you think of? What do you think about that strategy now, and how we kind of? It seems like we're finally learning lessons from these two major epochs in data. What do you think?
Well, it makes more sense indeed. But I think if we look at the history, back in the days, you had a big beefed server that was able to run all these queries. So it was easier to move the data across. And as we got more data, it became very difficult to fit every pipeline into the nightly batch load in such a way to get it into the central place. So that was one issue.
Right.
We had more geo-spread organizations. So that was harder to get all the data centralized as well. So we had to become more smart on how we fetch that data and build the insights. And I think technology helped us as well with the evolution of the internet. If you talk about 25 years ago, I just had the ISDN line in my house to have a speedy internet connection just
Right.
after the modem, how to dial up and into the BBSs just to sketch a bit on where we came from, and everything evolved. The speed of the network connections increased. We had cheaper storage to put everything through, and I think that made the evolution where we are right now. If you talk about the data lakes and distributed systems as well, where you partition your data and you spread it around, that's just the other way. Instead of fetching it, you distribute it over the various nodes to fetch that data and make it more accessible. And that together showed us as well, hey, there is another way on how we can get that data and build the insights. And we had as well another evolution. What I saw is more the servitized approach, where you were building software applications instead of the monoliths back in the days, like the AS400 systems. And this is how things became a bit different compared to centralizing all that data.
Yeah, and there are various ways you can deal with data. I remember the early days of data virtualization. There were companies like Denodo and Composite Software who saw this coming and they tried to enable that. Those were early days, and I think that it was difficult to do it back then. But Jay, I'll throw it back over to you. I think it's easier now. We have more sophistication, we have more knowledge, we have a greater capability, I think, to abstract out just what we need and create these virtual data layers, which are, I think, much more agile and flexible than this centralized repository that gets bigger and bigger and slower and slower. What do you think?
Yeah, we absolutely agree. Yeah. So, and then I think when you mash that virtual data layer up with the things upstream, like to the non-technical user and the business user, and they can trust it, and that's where some of the, I think, the magic can really happen. You know.
That's interesting. And it's because I'm just guessing here from years of experience in talking to people. You look at the data landscape today, and there are tens of thousands of sources. I mean, there's really no end to the sources that you can get. A lot of it from SaaS tools, for example. Still a lot of on-prem stuff, of course, IoT devices. There are all kinds of sources of information, and they don't all fit into the same box. So, we've tried for years to model ways to squeeze all this data into one space, but it's a difficult thing to do. And so better it is to take the approach of applying virtual models later. I think that for a while we talked about schema on read and the whole Hadoop world. It's somewhat similar to that, right? Where you're like, I'm not going to try to force everything to fit into this set of constraints. I'm going to recognize that the world is topographically variable. And then I'm going to let people figure it out on their own, which data sources to pull together, and then how to analyze that data. Is that about right?
Yeah, exactly. So the way we look at data set, we call it data set as a service, and it's the same thing as virtual data sets. And it abstracts all the underlying complexity of where the data is, how many different data sources is joining up together, how big the data is it real time, is it behind the scenes, and is it doing incremental stuff? But in our world, these virtual data sets are reusable components that the business can use, right? And then once you define it and say this virtual data set is good to go, you can use this and join it with other sources and create your own other virtual data sets. And what it also helps us do, it builds that world around that metadata and the data that we know and the fields that we've heard of so far. And that also feeds into the AI, the Gen AI stuff. So when you ask a question, we know what fields there are, we know what the data types are, we know what the values are in some cases, and then being able to when you ask a question, to have a higher accuracy of what gets returned back, and then the user can validate that what we've returned back is correct. And the other advantage is, like, once you have these data sets, you don't have to go in and rewrite those queries over and over again, right? And you use that, it reduces your compute costs on whatever the data source it is, because of these virtual data layers, and then also drive dashboards and visualization. So holistically, from an architecture standpoint, it just becomes a lot more streamlined and more
Yeah,
efficient.
that's very interesting, and that's an excellent point. I was talking to a guy from a big manufacturing company. He's a data governance guy, and we were talking all about Snowflake, and now they have this zero copy clone
Mhm.
capability, which is great. Make no mistake, it's very interesting stuff. But he said, I can't always solve every problem I have with compute, because if you get into some of these more complex use cases, you wind up getting a whole lot of compute being racked up to solve what could have been done in a different way using a virtual data set, for example. So, yes, there are plenty of advantages to having this zero copy focus, where it's just one copy of the data. The data is well, relatively immutable unless you want to change it. There are advantages to that, but there are also advantages to other ways of doing things, other ways of slicing and dicing the problems. Because, to your point at the beginning of the show here, you have to meet clients where they are. What are they trying to do? And every enterprise environment is different. I don't care what anyone says. I guarantee you, every single enterprise is different in terms of the technologies they have, the data they have, the people they have, the resources they have. All of these things combine to create unique entities that are enterprises. And so, being able to bring your technology to deploy in any number of these different environments, however topographically challenging they might be, is very powerful. And I think that the whole storyline about just one copy of the data, that is good for data governance and for some other use cases. But in terms of enabling the flexibility that companies are going to need to be able to quickly build use cases, test them, prove them, put them into production, build new use cases, test them, prove them, put them into production. That's the path to success with business intelligence. And that's what I think you guys are enabling. But folks, don't touch that dial. I'll be right back. You're listening to Inside Analysis. All right, folks, back here on Inside Analysis, talking to Jay Gopalakrishnan from Knowi and Yves Mulkers of 7W Data. We're talking about new ways of doing analytics, decision support, analysis, business intelligence, whatever you want to call it. It's all pretty much the same stuff. And it's a very topographically diverse world out there now. There are tons and tons of data sources, and there are these new amazing engines called large language models. You heard Yves talking about that a little bit. And I'll throw this over to you, Jay. Based upon what you said in that last segment, I'm guessing that you are part of a RAG model, or you know how to deploy a RAG model, retrieval augmented generation. And the real key are these anchors of truth and understanding what are the fields, like what are the fields in the data, what's some context around them. And if you nail that down well and you have good embeddings of your enterprise data, you can get a lot of good traction from these large language models, but you do have to govern it and be careful about it and curate it, right?
That's exactly right. So for us, we have a couple of constraints in terms of using off the shelf, the OpenAIs and the cloud-based AI services. We can't have any of the data go outside to them, right? So we call it. So we've launched this AI service that sits next to our core platform. And this AI service is basically a combination of an open source small language model. So, and when I say small language model, by default is Mistral 7B, right?
Okay.
But it could be anything else that can be plugged in. And the expectation there is that over time, these models are going to get smaller, more efficient, and generally get better. They can run in much more commoditized hardware. And then also comes with a vector database and LangChain and other things that gets wrapped around as a service. And what we do is, I talked about the virtual data sets and the data set as a service layer earlier, right? So then we can lean on this AI model to, when a user asks a question, that context of that question. You don't have to go and define synonyms and things like that around the data sets anymore, because with the AI model, it will just generate, we can piggyback on it to generate the right things based on the right data set, that we have our core processing and then lean on it for higher accuracy and return the results back. And what's really important for us is like, we can't make up stuff, right? And this is an inherent problem with these language models, where it would just, it's doing the next token prediction essentially, right? So for us, what we end up doing is that you have this rules-based world and this AI engine, and then you're forcing the two together. And so when you ask a question, we need to show the user, how did we come to this conclusion and this calculation? And did we get that right? So it puts the power back into the user. These are the calculations that we ran. You can change it if you got something wrong. But it allows us to achieve like 80% or thereabouts on questions that people ask on their data.
Wow. Yeah, go ahead. Go ahead. That's good.
Yeah, so for us, the AI service enables three main things on the core platform, which is generate dashboards automatically, right, from the data. What do you think is important to the user? Is it, easy way to get started for that user. The second bit is being able to ask questions on the data and generate results, and then being able to validate. And the third one is being able to summarize the data, or there's things that are happening on the data. So we check out these events, anomalous patterns detected for these data sets, etc. You can use the AI model to summarize it and get packaged up what is it that you need, and send it back to the user on Slack, Teams, or other channels. And where it also becomes interesting is some of our long tail things that we wanted to do, it's helped us accelerate that. So what I mean by that is, oftentimes when you look at data, it's data that's structured or semi-structured in your data warehouse, in your cloud services, and so on. There's a whole set of other set of products that exist solely to act on document management and documents, right? So and documents are ultimately also data in your PDF documents and the Word docs and the Excel files and so on. And the RAG-based approach allows us to also be able to ingest these documents from SlideShare, or you're uploading documents and so on, and say that also coexists with your other data. So when you ask questions on your data, we can now say, hey, this contract amount was this from this document. And what we're also working on is taking those bits and making that part of your data set too. So it becomes part of your data that you can chuck it into Snowflake and so on as well.
Yeah, that's really cool. Eve, I'll throw it over to you. I mean, I'm reminded a little bit, again, going back into the past, of Progress Easy Ask, where you would write a natural language query and it would show you the SQL query it's building underneath, right? So it's not new stuff, but it's newly innovative and newly achievable, I guess, in these environments. And, being able to see what the engine did and then curate that and correct it, I think that's the key to very refined, very accurate analytics. What do you think?
Yeah, that's exactly the thing. Now you think it's the conversational part from generative AI which helps. I was thinking through on how we built the systems back in the days. You had to build the enterprise data model, which takes about 2 years before you get some ontology and understanding of the business, building the pipelines, the data warehouse, before you could even start to question your data which you had into the organization. And now with this approach, this helps in quickly iterating, just trying something out and see if this is right, like Jay was telling. And if it's not right, you just change your question, you just add some data, and you reiterate. And I think that's a big advantage of how you can now build these type of systems. It's the agility what you get in questioning your data and moving forward on that. And even just one person can do that. You don't need the business analyst, the data engineer, the data modeler, the whole Big Mac that was building the data warehouse. And I think that's a big advantage where businesses really can use the insights on the data. And I think this is just the start of what we see in information management and what we can pull out of your data. And the simple way of building the ontologies in a simple way, or let the system build that for you, and you can say, no, this was not right, just tweak it, this sounds more like it. And this is exactly what you're doing if you're just playing around with ChatGPT. It gets something back and you just tweak your answer and you get the new answer back. It's pretty hard because you have to learn how to put your questions forward. And this was typically the role of a business analyst back in the days where they reformulated that question. And I think that's the part where we need to guide business people that are not used to ask these type of questions on how should you ask these questions to get the right answer or the answer that you're after. So yeah, we're in a very interesting world where this is finally lifting off. Still questioning because you see the hype cycle of generative AI is already going down a little bit, but it's because we thought all the vendors sold us AI is the golden nugget again. It's gonna solve all your problems just in a jiffy. But we understand that the architecture is much more complex to get this solved. But anyway, I'm still a strong believer, although that the architecture is pretty complex, that this is the way forward for the future.
Yeah, that's interesting. Let me ask you this question, Jay. You talked about how you deploy an AI environment in the cloud. Is that a multi-tenant kind of thing, or does each client have their own version? And then the second part of that question is when you're curating something, is that all being done like inside your RAG model, basically sort of a marshaling area, almost like what is it with Databricks? They have, I think they call it Delta Lake or something, which is where the changes are captured. Is that how it's done, or are you actually fine-tuning a model when that happens?
Let me address that, but also just take, it also there's partly correlates to something you mentioned earlier. When you type in a text and then that gets translated into SQL, that's like the first thing that people think about, right? When you look at NLP.
Yep.
And what we came to the conclusion when we started working at NLP many years ago was that you don't want to be doing that. And the reason why it's relatively easy to do, especially these days, but there are two problems with it. One is security, right? So any questions you ask gets translated into queries and run against your underlying data store. If certain people are allowed to see certain data sets and the elements of data within it, then being able to run these ad hoc queries becomes an issue. So that's one. The second bit is you also don't want arbitrary queries running on your data warehouse or data store and just run up compute just in case you ask something and it hitting a table with 2 billion records, and then so then you end up refactoring what the data sources are that are NLP query enabled with security permissions and so on. And going back to what we said about the data set as a service and the virtual data layer, what you can do on that virtual data layer is to control permissions on who sees what, including role-level permissions and all the rest of it. So when you ask a question, what we end up doing is we first do a search across all the data sets that that user has access to with appropriate role-level permissions too.
Oh, interesting. I
Right.
see.
So then it's like basically saying, hey, what's the campaign performance for Facebook since yesterday? And if that user only has access to Facebook and not Costco, then we know that this user is looking to get an answer from the ads data set and specifically for Facebook, and they're only allowed to have Facebook, not LinkedIn or other ones. Right. So then that gets translated into that data set layer where all the permissions are controlled, and then you're basically shielding your underlying data sources from these ad hoc queries that can go errant or run up your compute. So,
Yeah, that's interesting. And so you've solved also the security, the governance side of the equation, because security and
yeah,
governance are the same darn thing if you get right down
yeah,
to it, right? If you're
yeah,
governing something, you're securing it. If you're securing something, you're governing it. I mean, there may be
yeah,
additional functionality that governance wants that security doesn't, and vice versa, but it's the same thing basically. But it's a very clever architecture because you are protecting the data and you're also protecting the cost run-ups on these queries, right, Jay?
exactly. And then helps us solve a bunch of these things, and the RAG model comes in handy to find which data set we should question should go against, and also what the metadata is and the fields associated to it and so on. Yeah.
Yeah, see this, you're speaking to one of my big themes these days, and I'll let you comment on it, and we'll bring Eve in as well. But it seems to me that this RAG model is the new battlefront. And basically every software company and every end user company is going to figure out where do they fit in this world? How are they going to cater to this world? Because it is the new reality of how to do things. And it makes sense because we have these very powerful engines we want to use, and we want to use our corporate data, but we want to protect it. So that's going to happen inside this RAG model. You're going to get security, governance, data quality is going to be baked in here. A lot of these rules that we've developed over the year, rules-based systems, are going to be inside that RAG model. And so I think it's very important for, like I say, software companies and end user companies to figure out how are they going to live in this new world, because it is a significant transformation. It's a whole, another whole layer in between all this stuff, right?
Mm-hmm. Yep. Yep. Exactly. Yep.
Yeah. Yves, what do you think?
Yeah, I think you can well nuance a bit the answer on that, because the rag part is where you add your own data on top of the foundational model and the very generous models. That's where I see that the rags are adding this. Part of what you say, I think, is true, where you have to have the governance and the security in there, just showing what data can come back and is provisioned to the person questioning or forwarding that question to the model. But the RAG is not always needed to add your business data into it. If you just take the generative, the general models like ChatGPT or Claude or Gemini, you don't always need the RAG in such a way. So I think we have to be careful on saying RAG is just a provisioning layer for everything where we're communicating with the large language models in a general way.
Yeah, that's an interesting point. And we got about a minute and a half left here in this segment. And I like that you came right out and said Mistral, right? Which is this mixture of experts. Can you give us just like a 60-second explanation of how that works and why it's important, Jay? Go ahead.
Sure. So the model selection for us was like, how can we run this on premise, like within our cloud environment and also in the customer's environment, and keep the hardware costs, the cloud costs to a reasonable level. And then also how can, we see the Gen AI stuff as like, how can we help our customers, and what value can they get from their data and the documents quickly? And that's, the between all the model selections that we tried against, this seems like we just keep coming back to it. But the way we architected that is like, hey, we're going to get better models over time. So how do you swap them out?
Oh, right.
So being able to just configure that new model
Yeah.
comes.
That's an excellent point. I mean, that's an excellent point. I've heard a lot about Mistral, and I think this mixture of experts approach makes a whole lot of sense. And it's a difficult decision that CIOs and senior executives are going to have to make. Do we go with the big guns, knowing that they're going to be innovating and they're going to be doing cool new things? We don't want to miss out on that, but we also want to have control of our own environment. We also want to be able to be flexible in our own environment. That's where the small language models come into play. It's like this is going to be a debate that goes on for quite some time, folks, but don't touch that dial. We'll be right back. You're listening to Inside Analysis. All right, folks, back here on Inside Analysis, talking all about new ways of doing analytics. You don't have to do a data warehouse. You don't have to do a data lake. You can have more of a federated approach. And we're talking to Jay Gopalakrishnan from Knowi, and of course, Yves Mulkers from 7W Data. And I just got an idea as you gentlemen were chit-chatting in the break there, Jay. I'll throw it over to you. You think about these spaces or domains or disciplines like CRM, for example, customer relationship management. We're seeing a lot of activity around customer data platforms these days for obvious reasons. I've heard some very interesting theories about that, including a company that has he calls it a very opinionated data pipeline, which I think is kind of fun. But what's interesting is that CRM really boils down to an amalgam of automation and data persistence and the ability to analyze things. And that's the kind of stuff that Knowi enables. Now, you may not want to call yourself a CRM solution, but where I'm kind of going with this is if you have a flexible architecture and you can deploy automation, algorithms, for example, data quality, data analysis, well, that's kind of what a CRM is anyway, right? So is this more of a Swiss Army knife approach that you have now for doing all kinds of analytics that is flexible enough to change over time? Because I think that was Yves' point in the break, that you go into building like a HubSpot or a Salesforce or something like that, and you have a certain set of processes in mind. But if then you realize you were wrong, some of these systems, it's hard to change them. Um, they're very brittle in certain senses. I mean, they're flexible in other ways too. But having this sort of abstraction layer in which you can play around with automation and algorithms, et cetera, does that make you a much more flexible tool than what's out there otherwise?
The way we look at it ourselves is like, hey, how can we be the data, foundation for companies all the way from where the data is to the business user, and that includes data in CRM systems. I mean, I wouldn't call ourselves a CRM necessarily, but we collect data from Salesforce and we collect data from HubSpot and combine that with our own like product usage data and so on, and then send that to our customer success folks, in use cases like that. But so for us, it's like that foundation from a company for everything data related, where you have different data sources.
Yeah, I'll throw it back over to Eve. I mean, you were talking about the need for flexibility. And when you're talking about analysis, well, obviously, you need the data to analyze something, but you also need the algorithms, you need the compute power, you need the sophistication, you need to be able to model it a certain way in order to ask those questions. And what's interesting is that these models, these foundational models, they're very good at doing a variety of things. Now, they're not so good at doing other things. They're not really complex math engines, for example. And people try to use them for that and then mock them and say, ha ha, it didn't work. I'm like, all right, well, I think you just misused the tool there. But point being, we want to be able to leverage what these things can do, and they can do some interesting stuff. Some complex ETL, for example, they're pretty good at that kind of stuff. And so having an environment where you can leverage the capabilities of a data processing engine versus a language model, that gets very interesting. What do you think in terms of flexibility and in terms of being able to meet business needs? This sort of architecture Jay talks about is pretty compelling, right?
Yeah, and in terms of flexibility, these models are very, very handy. Let's call it like that. I've been playing around with the various language models as well to program some Python code, and it's amazing on what you can do with that. And that is because there is already such a solid code base available where already so many people solved so many problems. And I think that's where the advantage is. In being creative, that's still a different discussion on doing some different stuff. But I think we've already built so many ETL or ELT pipelines back in the days. We did already so many types of modeling. All the optimization things that we invented over the last 25 years as a data engineer, as a data warehouse builder. That's information that is already available. And if you look at GitHub, what type of information is on there, why would you reinvent the wheel instead of putting on a large language model on top of that code base and helping you or augmenting you in the type of technical work what you are doing? We're still at the verve of all of this capabilities, what I see, but it helps us speed up. There's still lot of errors which are going on, and that's fun to see if you're playing around with a ChatGPT or a Claude when you're writing Python code. You still need to have the capability of understanding what has been written, or the just find the errors in the code and such on, and guide the model on where you want to go. It's still not still pixel perfect, but for simple things, it's bam, you got your function and it augments you in such a way. And this is the step for just coding. But I can imagine that we will get a lot of more other stuff being available in the future as we use more and more data that can support these larger language models of doing that.
Yeah, and Jay, I'll throw this one over to you. I think what we're going to see over the next few years is these language models and other foundational models will advance in a variety of ways, one of which will be layers of functionality. So, layers of reasoning, for example, or layers of traditional relational analytics. It's like, well, why couldn't you come up with an AI model that achieves what a relational database wants to do just in a different way? Now, I know with the language models per se, they will always be probabilistic because they convert text into numbers, then numbers back to text, or images to numbers, numbers back to images. So it's never going to be perfect in a certain sense, but they'll be darn near close enough to get the job done. I mean, what do you think about managing and sort of shepherding your own development processes with all that in mind?
So I'll tell you some of our like long-term roadmap things and where things fit in. So one of the I mentioned the AI engine and how it helps with certain product features and functionality. And for near term, we're putting together a conversational interface where you can basically just have a converse with the data, where it remembers context, but also do things with that. So an example would be, hey, what was my open rate for the Facebook campaign? Going back to that same example, and it gives you a number. You can validate it. I said, oh, and then also, hey, can you send me create me a dashboard and send this to me on a 7 p.m. or 7 a.m. Every Tuesday, right? And have that taken care of, right? And then also validating that we've done the right thing, understood the right context. And then taking that up step further, let's say you get a notification to say, hey, the open rate for this campaign has gone down drastically in the last week. And then someone looks at it, takes the right action. But imagine a world where you trust the AI systems enough, especially with low-hanging fruit type of cases,
Right.
where, hey, this open rate has dropped. Do you want me to go in and take those actions? And if you configure it and say, hey, I need to go in and tweak these things on Google Ads here, for example, and having the right agents that can do that on your behalf
Right.
within the company, and having these agents get that, that's the path we're working towards. I mean, that last bit is still some far away, but and then it ties back into that whole data foundation piece, right? So if you have the data, if you have all the data sources, you can join them together, ask questions, and take action. That's the
Yeah, that's the holy grail, as we used to
yeah.
joke, right? I mean, when you can get this this layer of awareness combined with the capacity to automate and to pull levers, because that's what you're talking about basically, especially if the set of lever pulls is fairly known, meaning just basic stuff like your website goes down, restart the server, right?
Exactly.
You get a piece of information, hey, the site's down, boom, go restart the server. That's a very simple automation. But some of these AI agents are going to be significantly more sophisticated in being able to discern what to do based upon multiple sources of information. And, and Eve, real quick, we just got a minute left here. In the troubleshooting world, that stuff gets really, really complex. So even if they can just suggest what to do, that's some meaningful value right there, right, Eve?
Yeah, I think you just quoted correctly. The next best action, what you see typically in just online shops, is very helpful on what to do. And if you already get somebody or a system that guides you into taking that action, yeah, you can move much more swiftly in trying to solve your issue or doing root cause analysis. And that's really a big point what we are being capable of doing.
Right. I mean, it's why you see all this activity in the observability space. I mean, I went to the Splunk conference about a month ago and I just looked at some of those dashboards. I was like, oh my goodness, I would not want this for your job, man. You're just like hacking through the dark forest at night with like a little lighter trying to flick and see if there are any monsters right near me. Oh no, there's the monster. It's complicated stuff, but folks, our podcast bonus segment is coming up next. Send me an email if you want to be in the show, info@insideanalysis.com. You're listening to Inside Analysis. All right, folks, time for the podcast bonus segment here on Inside Analysis, talking to Jay Gopalakrishnan of Knowi, that's Knowi, and Yves Mulkers of 7W Data. When you know better, you do better. That's the whole storyline of the show. Today, I'm a big fan of cliches. And Jay, I'll throw this one over to you. Another buzzword that's been floating around the last few years, unified analytics. Now, typically that refers to having analytics on this set of data, on that set of data. How do we reconcile these things? Well, we know master data management came along as a way to virtually reconcile information sources so you can align along customers and products and regions or whatever the case may be. But unified analytics, from your perspective, is something a little bit different, and you seem to have a fairly comprehensive answer for that by design, right? Talk about what you mean by unified analytics.
So when we started the company, I used to run products at a prior company where we had, we wanted to get embedded analytics to our customers, but our data was in 19 different silos at the time and growing. Right? And these silos not necessarily like structured. So you have Elasticsearch in the mix, you have Cassandra in the mix, and you have SQL databases in the mix. So it wasn't really realistic to have all of those into a warehouse, but the warehouse concept itself wouldn't have worked for us anyway because of the amount of volumes and and the data transfer and so on. So the concept then was the whole approach seems wrong. How do we do this where you can just unify all your data regardless of where the data is? Some of the data doesn't need to be transferred either, right? So how do you collect what we can collect and that you can care for the user? So the unified analytics concept for us was how do you connect into those underlying data sources regardless of where the data resides in which data center? How do you combine them? How do you then cleanse, transform, get that right data sets going? Goes back to the virtual data set layer that we talked about earlier. And there may be cases where you need to run these asynchronously. There may be cases where you need real time. How do you do all of those use cases in this unified platform without having to, move the data? And then the industry went on this modern data stack concept where you take the way you do that is you grab the raw data, move it into the data warehouse, and then do transformations on top. And our approach was no, just leave the data where it's at. Get things on the fly that you need, and run things asynchronously where you need it, and then the resulting data sets you can store where you want it, and then you put the dashboards and visualizations and the BI layers and the drill downs and all of that stuff on top of that. Then you get this unified platform instead of having to cobble together multiple different products.
Yeah, right. Well, it's a very nifty architectural approach that allows you to optimize which data you're using where. And Eve, it kind of reminds me of in a business intelligence world what Mesmo does with observability data, because it's the same approach that they're taking, where their argument was basically like, look, if you go with any of these observability vendors, Datadog, and New Relic, whatever they are, their out of the box storage sounds good at first, but then over time you wind up having tons and tons and tons of data, and it becomes a problem. What do we do with all this data? Mesmo's approach is, hey, we will be the marshaling area that allows you to determine what signal you're going to pull from this and then where you want to send the rest of that data. Maybe you throw it away, maybe you send it to cold storage. You do whatever you need to do, but the point is they took a very strategic approach around the information architecture itself and how to optimize the value of the data that they're pulling for analysis, right, Eve?
Yeah, it's exactly the same what we saw happening with big data 12 years or 14 years ago. Storage became all of a sudden pretty cheap. You had your compute on just standard hardware, and that's where people said, okay, let's gather all the information what we can gather just to use about 5% of all the data that has been gathered. One of the examples I recall was eBay that put it down from 5 petabytes just to a few megabytes, just because this was the data that was valuable for their business. So there is a shift in how we should approach that. The same goes with IoT. You just touched upon that, Eric, where we say in the beginning the idea was to get all the data from the IoT devices, but because it's too big, you just look at the aggregated data and take that down, and all the detailed data what you maybe need in the future, that's something you will store, but the rest you just abandon. And I think it's like our mind is working. If you say the things that are really important, you put it somewhere in your brain, the other ones go back in the archive, or you just put it away in a certain way. And if you think on how the brain works, that's how we should look at the information that comes from the business, and not trying to get everything in place. With the technology, we're capable of doing that. So I think there is definitely a very big opportunity where we will have easy access to any kind of data that has been ever produced. But future will show if we can still store all that data in
Right.
data centers and still have enough of our power and energy to feed the data centers. But that's a different discussion.
Yeah, well, for a final comment, got about 2 minutes left here. I'll throw it over to Jay. One of the thoughts lingering in the back of my mind is that these vector databases, depending upon your use case and how you're trying to leverage your information assets, can serve as a very valuable repository. And I think about certain heavy imagery like MRI scans, for example, things that take up a lot of disk space. Well, you could put some of that into cold storage because you have to keep it for patient records. But in order to be able to analyze large data sets like MRIs across 50,000 patients, for example, that's something that vector database is very good at for being able to delineate this version versus that version. I think it's going to really change, again, the cost structures and the architectural approaches you take to storing your data. What do you think, Jay?
Absolutely. I think you use the right database for the right job, right? So within our architecture, we have relational databases for relational stuff, users, rights, roles, were these data sets and who has access to it, that sort of stuff. And then you have vector databases for the RAG side of things, right? And being able to find the right data sets and so on. And then you have a semi-structured data for our Elastic Store mechanism, right? And we also use Elasticsearch in between. So it's like multiple different data sources because we couldn't really find one database that did all of this well enough, right? So
Right.
it's like, even though the trend is going that way, it's just not quite there yet. So
Right.
these databases were built from the ground up for specific, storage or compute, things. So for the image stuff, there may be a separate
Right.
database or data store that can be stored.
Right.
Yeah.
Interesting times, folks. We'll look these gentlemen up online. Yves Mulkers of 7W Data and Jay Gopalakrishnan from Knowi, Knowi. Very cool approach. I love these architectural solutions to data management problems and analytics because it's very unwieldy out there. And the more flexibility you can bake into your system, the better you are going to be. Send me an email, info@insideanalysis.com. We'll talk to you next time. You've been listening to Inside Analysis.